Okay, now we want to consider what happens on the capital B here with respect to this tangent function. So I want to consider a couple of examples, and we're going to do these for one period of the function, because once you know what's going on for one period, it being periodic, you know what's going on for the rest of the number line by repetition. So I'm considering y equals, say, tangent of 1/2 x. Okay. In general, my period is going to be a pi over b here. So I have pi over 1/2 is 2 pi. You might notice that the period of tangent was pi, period of a half x is 2 pi, tangent of a half x is 2 pi. Essentially my x values have to be twice as large to compensate for the 1/2 here. And then I want my 1/4 of my period should be then 2 pi over 4 is pi over 2. And so I'm going to have my points of interest here, right? So I'm going to have, here's 0, pi over 2, pi, it's negative pi over 2, negative pi. And what you might notice here is on these extrema, we're going to be in trouble at pi and negative pi, because tangent, if I put pi into my tangent function up here, right, then I'm in trouble because the tangent of pi over 2 is undefined, and near it we have vertical asymptotes. So here would be 1, here would be negative 1. So I have something like this. I'm going through the origin here. I have these points. And so this is my graph of one period of that function. Okay, now we'll consider another example of y equals a tangent bx. The b, so I want to consider y equals the tangent of 3x. So I know that my period is pi over b here is going to be a pi over 3. So 1/4 of the period is going to be pi over 12, right? You multiply pi over 3 by a quarter, you have that. So this is going to look like the other ones we just did, but these are shrunk in a little bit. So now I have pretty much my same graph, but I have 0, pi over 12, 2 pi over 12 is pi over 6, negative pi over 12, negative pi over 6. And you can think about plotting points, but essentially I have the same exact behavior here as before. And here's 1, down here is negative 1, going through here, here, those 3 points, and then these asymptotes. So this is what my graph looks like, okay? And it's shrunken in here. So, except for the scaling, they're all pretty much the same. Okay, so in summary, if I have y equals the tangent of bx, where b is bigger than 0, I can get its graph by graphing the tangent of x and stretching or shrinking horizontally. So you can think about what this looks like. Okay, so maybe I'll first draw my tangent function like so. So this is going to be y equals tangent of x. Okay, and then I want my tangent of a half x. I'm going to double all my x coordinates, so I have to sort of think about doubling those guys, right? So this would be y equals tangent 1/2 x. And then for y equals tangent of 3x, I'm going to have a third of these values. Okay. So I haven't drawn the asymptotes because it'll clutter up the screen, but basically you see how my x values are. And another thing is that, of course, this is just one period. Your actual graph, you're going to have, period after period here. So we would have on all these guys, right? We would have our asymptotes, right? Equally spaced here. And so we're going to have something like this, right? Something like this, etc. So that's my graph of the whole thing, right?